Perspective Class 7 Video 3. In this video we're going to do an example involving parallel projection. So let's go straight to the example. The example reads, the points -1, 0, 3, 1, 0, 3, 1, 2, 3 and -1, 2, 3 form a square in the z equals 3 plane. And I've drawn a picture for you here. So here are the points plotted in three-dimensional space, and they form the vertices, the corners of a square, which I've drawn with dashed lines. And the question just says calculate the image of this square under the parallel projection onto the onto the z equals 1 plane. Okay, so I want to parallel project onto the z equals 1 plane and then sketch the outcome. Well, you can probably guess before you do any algebra what the image is going to look like. Like if you imagine trying to draw the z equals 1 plane, it's like a horizontal flat plane, and then each of these points is going to get mapped down like this, and this is going to be the answer. Okay, and that's a terrible picture, so I'm going to erase it so you don't have to look at it, but that's generally what it's going to happen. So let's do this algebraically. Well, the point -1, 0, 3 projecting parallelly onto the z equals 1 plane, all I do is I change the z coordinate from a 3 to a 1. The point 1, 0, 3, all I do is I change the z coordinate from a 3 to a 1. The point 1, 2, 3, change the z coordinate to a 1. The point -1, 2, 3, change the z coordinate to a 1. So here are the new points. These are the images of the old points. Okay? And now I'm going to try and plot them on a z equals 1 plane. This here is a z equals 1 plane. So I'm going to plot these points. Okay? So for example, this first point here is -1, 0. So that's this point right here. This point here is 1, 0. This point here is 1, 2. And this point here is -1, 2. And then you can join them up if you want, and you get a square like that. Okay, so the image of this square in three-dimensional space projected onto the z equals 1 plane is another square. Let's do another part of this example. So same starting square, but now I want to project it onto the z equals -100 plane. Okay, so the way you think about this is, the first question had me project it onto the z equals 1 plane, and the z equals 1 plane is like sitting here. The z equals -100 plane is sitting miles down here. It's sitting a long way below everything else. So that means these points have to go all the way down. Okay, and this is an utter mess, so I'm going to erase it. But that's the general idea of what's going on. Okay, so let's just do it. Projecting onto the z equals -100 plane. So all you do is you replace the z coordinate with -100. Replace the z coordinate with -100. Z -100, z -100. Easy as that. And now I'm going to plot it on the z equals -100 plane. Okay. Well, what do I see? -1, 0, -1, 0, 1, 0, 1, 2, and -1, 2. So it's actually exactly the same as in this case here. Like the image, the result of doing the parallel projection is exactly the same if I project it onto the z equals 1 plane or the z equals -100 plane. And this highlights something which is important about parallel projection, in that parallel projection can't tell depth. So in parallel projection, you can't tell how far away an object is. I mean, in this first case, I was projecting onto the z equals -1 plane, which is pretty close to the original starting square, right? Z equals -1 is pretty close to the original square. And in the second case, I was projecting onto the z equals -100, which is a mile away. It's miles away from the starting square. And yet the image looks exactly the same in both cases. parallel projection, it cannot distinguish depth. Okay? Or another way of saying what I want to say is, in parallel projection, you cannot convey how far away an object is. Okay? In parallel projection, it's impossible to convey how far away an object is. Let's do a couple more parallel projections. So same starting question, but this time I'm going to project onto the y equals 3 plane. So all you do this time is you replace the y coordinate with 3. Replace the y coordinate with 3, y coordinate with 3, y coordinate with 3. That's all you do. And now you plot it on the y equals 3 plane, which is this plane right here. And because it's the y equals 3 plane, the coordinate axes are now x and z. Okay? So what numbers do I plot? Well, if I take this thing here, I want to plot it on the y equals 3 plane. So I already know that y is equal to 3. So just ignore that. What you're plotting is that x equals -1 and z equals 3. So in particular, you have that -1, z equals 3. That point there. Okay. This one here is 1, 3. That point there. This one here is also 1, 3. Okay. And this one here is -1, 3. So you just get 2 points because they're like double points. Okay. And the image is just this short line segment. Finally, let's do what happens when you project onto the x equals 2 plane. So when you project onto the x equals 2 plane, all you do is you replace the x coordinates with 2. So whatever the x coordinate was before, forget about it. Now it's going to be equal to 2. And you're going to plot this on the x equals 2 plane. Because it's x equals 2, now the coordinates are y and z, like this. So this first thing here, you plot this, ignore the 2, you're just plotting 0, 3. 0, 3. This one here, you're plotting 0, 3. This one here, you're plotting 2, 3. And finally, this one here, you're also plotting 2, 3. Okay? So it's similar to what happens when you project onto the y plane, except it's a bit shifted now. Okay? All of these images are just different perspectives, different angles on the exact same square. Okay? So that's the end of this example, and that's the end of this video.